I like when you mic drop, you just info drop.
He said he's not going to give us homework.
Please get this in your plan book. Notice! Eyes and ears. Choose 7. There are 10 problems in the homework. I don't really need you to do all 10. I just want you to get a spattering. They're all very similar. Choose 7 of them. Essentially skip 3 of them. If there's like, oh, look at that big ugly, oh, I can skip it. So you have the freedom to skip whatever 3 you want. Cool?
Cool.
Okay.
What are you doing?
I'm trying to make your life easier. Promise? I'm not here to make your life harder. So, 8 through 17, choose 7 of them. Can I make this picture bigger now?
Yeah.
Please get out last night's homework. Take this opportunity. I know some of you won't be done with it. It's okay. A couple of you texted me and I verified, yeah, it's not due the next day. Take this opportunity, if you worked on that last night, to check with your teammates. If you have any questions about things, ask them about your issues. We will go over this again tomorrow. I just wanted to give you a couple minutes to chat about problems, see if anybody's having the same trouble as you. It'll take 2 to 3 minutes. Check last night's homework with each other. It was not.
Oh, it was. I didn't tell it.
But it's good.
It's not really a question as much as like your question. It was go through every kind of question. I assigned color.
You'll need the handout, and I
I think so.
No, I remember I had
you need this here in all the problems.
But
Not right now. You
anyway,
can put your
I
name
made a
on it.
little green. Yeah. Well, no, you did it wrong, so you have to fix it.
I mean, you can move things. Or, so you can also.
Shut up. Okay. I'm still not getting.
It doesn't have to be all nice and pretty. Yeah.
They were confused.
Yeah.
I just don't know what the church is. I just wrote it.
I put that on
Yeah.
Yeah. Sorry, I just
And take the next minute or so, transition to being able to take math notes. We will be in 211 today. Today is the 12th.
We're in our toolkit, right?
Yeah. So, toolkit should have plenty of space in chapter 2 right now. Toolkit should have plenty of space in chapter 2 right now. You should really specifically be on page 17.
Oh, yeah, 17.
So, ignore the... Shouldn't have had you open this yet either. When we talk about portions, okay, so just give me your eyes up here. We're just going to have a conversation to start chapter 2. By the way, this is the first time that things will really feel flowy. I really like CPM, even though I've never taught it before, but I dislike chapter 1. It's too random for me. We jump around a bunch. We talk about some cool things. Probability is fun to talk about. But it's, for us, especially us very academic people, we want to we were here yesterday, we're going there tomorrow, it all flows. It will start to feel like that now. I know it kind of felt a little jarbled in chapter 1, which I don't even know if that's a word, but so I promise you chapter 2 will start to feel better. But we talked about portions, right? The reason that we start the year with probability is to talk about the idea of a portion. So we have 3 different ways that we represent portions and that we did it in chapter 1, right? We can use fractions, we can use decimals, and we can use percents. So can somebody talk to me about how we use those with each other? And please, never mind, I didn't put up tomorrow's homework. Notice on math side, I put up tomorrow's homework. I wanted to make this announcement before I start doing it here with us. I will start to probably put up at least the next day, if not the entire week's worth of homework. I have it written down in my planner. I know what we're doing this week. I dance on the fine line of I don't want to overwhelm you, but yeah, I know people like to work ahead. So for those of you that don't want to be overwhelmed, act like it's not there. Like right now, it's not there. But later, probably during my planning period, I will put up the rest of the homework for the week and like what our plan is. The day we're taking the test, I will write there, team test. That's not your homework. That means that's what we did that day. So it'd be like team test, no homework or something. If you like to work ahead, there's your permission to work ahead. Do not come to me and say, I'm really confused on this, but I'm working 2 days ahead. Duh. So if you're working ahead, you can't ask me questions. Sorry. You can talk to each other, but if we haven't learned it, yeah, you're working ahead. I need to help people that need help in what we're doing right now. So when we talk about the ways that we represent a portion, how did we, like, so let's say we were given a fraction. What might we have done with that? Okay, you have two hands, I'm pretty sure. But yes, we might have changed it into a decimal. With what purpose? Like, say we had the fraction, I don't know, like 3/4. Why would we be changing it into a decimal? What purpose does that serve? Go ahead, you started it. Yeah. 3/4 of a dollar. Sure. Love it. 0.75. 75 cents. 0.75 of a dollar. What do you think?
You can also, it's easier to convert decimals into percents.
Ooh, how would that happen?
If you want to figure out a percent from a fraction, if you convert it to a decimal, then you take the first, tenths and hundredths place.
So sometimes, actually, we might, before you go there, I can't straight convert 3/4 into a percent, like right away. You can't, like, not really. I mean, once you memorize it, you can. Sometimes I go fraction into fraction. Here, what fraction into fraction would I have gone? 7,500. Yes. Then I can easily go into 75%. Now I could have also just gone from the decimal to the percent. And often, on the way, pictures helped. Right? So really what we see here is this Illuminati kind of synergistic sort of decimals, fractions, percent. They all work. Sorry, those of you rolling your eyes at me, Illuminati, I'm completely joking with that. Last year's class was all about the Illuminati. Anything that was a triangle, they claimed Illuminati. So that's totally a joke. But for real, seriously though, fractions, decimals, and percents have this very cohesive relationship. We want to be able to fluidly, it means like really smooth, really easy. We want to be able to fluidly work back and forth between fractions, decimals, and percents. So all through this chapter, please try, I hate the word memorize, but please try to like sink into your memory some of those common fractions to decimals to percent values, just so that it's easy to work with. Like, I can now tell you that 1/8 is 0.125. I could not tell you that when I was a kid. Now, what I think is gorgeous, might blow your mind here for a moment. Here's one way that helped me remember this. Once I realized this, and this is one of the ways in my pledge name when I was in a fraternity was numbers. Literally, that was like my nickname. 1, 2, and 5. Add up to 8. Now, hold on. Gets even better. 1/7. Now, I do not expect you to know that, right? We're repeating 6 numbers. 7 times 2. 7 times 4. Approximately 7 times 8. So, all these cool relationships, this is where we're going in chapter 2. Cool? Sweet? Awesome. Let's dive in. So, in your textbook, go ahead and open to 211. Actually, we're going to open to the intro to 2 first. I lied. So, actually, I lie. It's okay. But I always admit when I've lied. So, check it out. You can look on the board if you want, or it's in your book. Chapter 2 intro. So there's some guiding questions. You guys can take this time, or you can take time to read this later if you want. We're going to breeze through this because we have a lot to cover today. Guiding questions. How can we rewrite this? How can I re-represent that? Are things equal? All because they don't look equal doesn't mean they aren't equal. How can I visualize this? Think about pictures. Think geometrically. How can we describe the motion or the move or the change? And is there a better way? We want to make our life easier. So better really means easier. I want to make your life easier. So here's how this thing is mainly broken up. 3 sections. All right. Section 1 is going to look at numbers represented in fractions, decimals. We're going to get good at that. There's only a couple sections on this. It'll only take us a couple days. We're probably done with this week. Next week, we'll move into sections 2 and 3. Section 2, we're going to extend on length, multiplying positive and negative integers. Anyone know the difference between integers and rationals? Not necessarily. Integers do not involve any portions. Integers are all complete values. Integers mean entire values. Whether it's positive or negative, integers mean no portions. Ratios, or rational numbers, have portions. They are allowed to involve portions. And then 2, 3, we're going to review and start working on plotting and reading points on graphs, learn about scaling and showing relationships. So now we can actually dive into 2, 1, 1. I'm no longer a liar. 2, 1, 1. So check out A versus B. I want you guys to just work on 2, 1 and 2, 2 here for the next couple minutes. Okay, so once you get done with 2, 1, go ahead and work on 2, 2. Now 2, 2, you are helping Miss Maines, and you are trying to figure out how many cheese sticks we can give each of these 5 kids if we only have 13 to start. So take about 4 minutes, probably maybe longer. Work through 2, 1, and then 2, 2.
Okay.
Present each portion as a fraction and as decimal. That's 3/4, and that's 2/3.
Yeah. Actually, I meant to today, but because it's just kind of intro day, we're really yeah, we are. It's okay. Sometimes bonkers is okay.
Yes, it is 0.66. And a well, yeah.
But you know how some people write it 0.66 because they're rounding 6's off?
Yeah, but that's not right. It's 0.666. Yeah.
Sorry, I gotta pause you for a second to ask a question. This has nothing to do with your math. So chapter 1 only has a team test. By the way, you're not allowed to use calculators today. I don't think any of you are trying to, but just by the way, you're not allowed to use calculators. Chapter 1 only has a team test. It's only going to take us a day. Do we want to do that as soon as possible, like just do it tomorrow? Or, because I mean, your chapter 1 work is all due by tomorrow, your closure problems are due tomorrow, like we're wrapping it up. Or, do you want to put it off till Friday? Here's the pros, cons. Your chapter 1 test will be taken in these teams that you're sitting in now. Chapter 2, we need to get new teams. So, if we don't take the test till Friday, we're going to do new teams tomorrow and then have to get back in these teams Friday. Another pro, a pro of Friday, is no homework Friday. Always good to have no homework Friday. Now, pro of Wednesday, like taking it tomorrow, would be, I will show you the homework for the rest of the week. You could go ahead and get it done and still have a no homework Friday. The material's current, close in your brain, you're already at your team groups, and then we can just really dive into chapter 2 and not forget chapter 1, but not worry about anything left to do with chapter 1. So shut your eyes for a minute. I'm trusting you here. Not gonna make you put your heads down or anything dumb like that. Raise your hands if you would like to take the test as soon as possible. Might as well just do it tomorrow. It is only a team test, low stress. Those of you looking around, you are cheaters. Hands down. Raise your hand if you want to take it Friday. You do not like tests on any day but a Friday. And raise your hand if you could not care less.
Oh, I didn't know.
That's always an option. Sorry, I should have said that. All right, put them down. Open the eyes. We will be taking your team test. Now, if you're upset about this, there were people from every team who voted this way tomorrow. So your Chapter 1 team test, we will take tomorrow. I will tell you, from my perspective, there's one difficult problem on there. The rest should be pretty manageable. One is somewhat difficult, not like crazy hard, but difficult. Yeah. What?
Don't underestimate my ability.
Yeah, it is.
Nice.
Everyone.
All right, keep working. 2, 1, 2, 2.
You never know. You have to change them into a decimal.
Let's say 3 minutes. By the time the big hand's on the 2, we're gonna bring it back together.
Wait, wouldn't that be just
175. 3 out of 4, not 1.
Oh, yeah. Wow.
And then 3/4. Guys, for B, they have different denominators.
Yeah. What?
Yeah,
Wiring? I don't know. I like
this is like
very
really
tired
great.
today.
No, he really isn't. Orchestra
Okay.
music.
Yeah.
Okay.
Well, that's
Annie. You done? You need help still?
As a fraction and a decimal, right?
yeah.
So, I see fraction, and then what would be nice if you have fraction and then equal to its equivalent decimal. Then the other fraction equal to its equivalent decimal. You know, like, try to put them close to each other so it helps your brain.
You know
Yeah.
how when people write 2/3 as the 0.67 of reading decimal? Oh, that really is.
That's not true.
665.
What question do you have? You just answered your question.
Was it supposed to write the point?
She just said.
No, okay, no, hold on. You just said when it's really, right? So if you know what it is really, then
How do
it's,
people write it?
no, I mean, because sometimes we round, right? Sometimes you just have to round. Like a cash register would have to round it off.
It wouldn't be accurate.
Correct. The things aren't always 100% accurate.
I do it better.
Yeah, but I mean, talk to your team. If it's a good point in your team conversation,
No, we're gonna keep it.
just see what happens. It's heavy. No, but so the reason we do that is normally because where decimals have to end. You can't have a decimal repeat forever. Literally, like a computer couldn't deal with a number that actually repeats forever. So we write into code where it either rounds it or truncates. When you truncate, you just stop. When you round, you use the number after where you stop. So that's the difference between truncation and rounding. But when you write like computer code, it can't say it goes on forever because it can't, like, what is forever? What is the last decimal place?
That's confusing.
Right? Like, okay, so you're at your last decimal place. Go one more.
Okay, right. Okay, so the pictures and fractions. Yeah. The pictures and fractions. We should probably work as a team.
All right, big hand is on the 2. I do not like being a liar, so we might as well bring it back together and keep what I
They have
said.
different denominators.
The big block there. Let's go around there. Somebody from this group here, Oliver's group. What fraction of block A is shaded? 2/3, and when we represent that as a decimal, what is that? Now, we like to say 0.6 just because, and you said continuing. How do we write that? Ah, the little bar over it. Now, we would have gotten this if we did the long division, 2 divided by 3, or a lot of us just know that it is 0.6 repeating forever. And I had a great conversation over here about when would we use the 7 or not, unless there's a reason to round or stop writing your decimal. We want to write it as accurately as we can, So we use the repeating notation. Somebody from Naya's group back there. What about box B? How much of that is shaded? Ooh, so 3/4, so our fraction first, and then our decimal. So it would be nice if in your notes you showed that fraction equal to that decimal, that fraction equal to that decimal. I'm trying to figure out how to phrase this. What, like, without giving it away, what's the problem with a repeating decimal?
That forever, like a lot of people say this like number goes on forever, like 0.333 repeated forever. Like what is forever, and like how will we be able to like tell like how many digits is actually forever? Like,
So yeah, so it goes on forever, right? So this is how we write it, but I'm not showing the whole thing. And if I start trying to show the whole thing and I start writing it out, am I ever going to finish?
no.
So is it ever actually true?
No, because you could write more.
Yeah, right. Like, yeah, it's as close as possible. This whole idea to say sometimes the fraction is just better. Because this is as close as possible decimal representation. This is actually what it is. So sometimes your decimal values are better. Moving on to 2-2. Do we need more time, or are we okay to talk about 2-2?
A little more.
Alright, I'll give you a couple more minutes with 2-2.
Oh, 2-2. Any gotta go Oh, I'm just gonna put it right there with the denominator.
1 divided by 9.
Okay, in 2-2. Okay. Oh my goodness.
Hold on.
So let's really go ahead and transition this into a conversation. So, we talked with these two groups. So somebody from Mina's group, or team, I really need to start calling you guys teams. Are we, so first question, do we need a knife? Or a fork or something? Can we just hand out the cheese sticks? Somebody from Mina's group said that at the beginning of my statement.
Someone, I mean, you could, but then you have 3 left over. So if you actually want to use all of them and not have any left over, then you have to cut them.
So we had this, right, in our book, so we can give them out as whole cheese sticks. And then we had 3 left over. So then we cut them, right? So we give out our 2 to each people. Yeah, we're giving out cheese sticks, right? Visualize. 1. Another 1. So now I'm out of cheese sticks that I can give out wholly. Because if I just give 1, A, B, and C will get cheese sticks, and D and E will be mad. So, what's one thing that I could do to my cheese sticks then? Sure, now I want to make them the same size, right? So what if I just like cut them each in like half?
Then you still have half.
Then you can eat the last half.
Ooh, I have a half left over. Crap. So then I'd cut my half in, what, halves again or something? That's awkward.
You continuously be cutting a half into a half into a half into a half.
Now hold on. Not necessarily.
We're cutting it up somehow.
Okay, I agree with that, right? So we end up with that half left. If I cut these in halves, then I end up, and you'll see this happen, we can work with different sets of people, different numbers of cheese sticks. So I cut these in half, I give away these, and I end up with this left. So then I take that, and I say, I need to divide you to 5 people. 1, 2, 3, 4, 5. But what are each of these? A fifth of a half.
So be a 10.
So really, they're a tenth. And this is why a long time ago, someone really smart, probably smarter than us, decided to make a base system. Now, we've done you a disservice because time and all these other things get you way confused about base systems. So I'm here to clarify things. The number 10 is all that matters, right? So our feet, inches, yards, miles, that's all malarkey. Our seconds, minutes, hour, that's all malarkey. Base 10 is where it's at, right? That's where I want to make your life easy. Base 10 is how we make your life easy. Instead of cutting these in half and then that half cut up again, what if I just initially cut each of them into 10 pieces and just jump right to how many tenths of a cheese stick you can have? Do I have a way to represent with decimals how many halves of a cheese stick you get? Like, how would you represent? I'm going to give you a half of a cheese stick. 0.5, but that's 5 tenths. Our numerical system is based around tenths. So instead of cutting them into halves, what if I just cut into tenths to begin with? Well, how many pieces do I now have? 30. Can I distribute 30 to the 5 people?
Yeah.
And how many they each get is what goes in the tenths place. This is why our base system works how it does. You can change the number of cheese sticks you have, and you can change the number of people that you have, and you will always see that you have to end up dividing by 10, or divide into 100, or divide into 1,000, or 10,000 pieces. But either way, you gotta use some multiple of 10 if you're ever gonna end. Now, fortunately, this ends. So we know 13 divided by 5 gives us 2.6 based on that visualization. Another easier way that we could have done this. We started with 13 divided by 5. Each person will get this much, right? 13 cheese sticks divided by 5 people. Could I do this? Can I rewrite the fraction? What would it be? 26 over 10, right? So 26 tenths is a mixed number, right?
2 and 6 tenths.
Done. Equivalent fractions. Make your life so much easier. You don't have to do the division. Instead, just do some multiplication. And then, just think about what the number, 26 tenths is 2.6. Questions about that? Yeah. Okay.
I did with mine around, but I couldn't fit.
Okay.
Because then everyone would get 1/5 because 1/5 is equivalent to 2 tenths. And another way you could do it is if you have 13 bits, you have the 2 already from the 10. And then
Yeah. Now the only issue is how.
You would multiply it by 2 to get 6 tenths, same as you.
Right. So what you did works, but the only issue is how do we express it? We still then have to do some conversions because you said a fifth is 2 tenths, and you had like all this kind of in your head knowledge.
That's just
But
what
remember,
I had.
we want to make life easier. So I agree what you did works, but it might be a bit complicated. Like, so it works in your head, right? But it might not work in each of our heads. So this shows out what we did in that video. So if you need to go back and review that. 2, 3, and 2, 4, I have a handout. You have a handout. Go ahead and work this out on that handout as a team. Go ahead and work 2, 3, and 2, 4. I'll give you at least 5 minutes. By the way, I doubt I've said this to this class before. It took me a long time to remember which of these numbers would go on the inside and which would go on the outside. We know numerator and denominator. the numerator goes on the inside, is what I ended up having to tell myself. So when you set up the division, that's how you know which goes on the inside of the symbol. So I'm just going to give you my memory tricks as I feel fit. You don't have to use them. You don't have to use them, but that's how I remembered the numerator goes inside.
No, seriously. You can multiply. Sorry. Okay, so we could do 3 divided by 4, or we could do what he was saying and do 3 over 4, and then for 4.
Go ahead and do the long division. Yeah, show the long division.
Because 4 can't easily go into 10.
You can do it by 2.5. 2.5.
Can't easily go into 10. Like, integer
Well,
is
okay,
what
yeah,
I mean
then
by
I see.
easy.
Yeah.
Are we supposed to do it right here?
I'm just.
You look upset.
Do
Not
the long
furniture.
division.
Not.
3 divided by 4.
You can work it out on here. I mean, so each whole line in the diagram represents one piece. Are there enough whole pieces to put some in each of the 4 groups? So we're working through the problem, but with
Okay, but wait, I got
Take long division.
I got 0.75.
Hold on.
so you're taking 3, dividing by 4, or you're taking 2,
Yeah, we did it
dividing
so
by 3.
much. The entire year last year. Oh, I think we should do it on the line then. I don't care. Oops. Oh, oops. Okay, so do it again then.
So if you're reading the directions in your book, the lines actually represent kind of like what we did with cheese sticks. So if we had 3 cheese sticks to divide to 4 people, we already know the decimal, right? We know it's 0.75.
So
How do we
there's 3,
visualize
and you would have to put them into
Doesn't work like that.
4 people. 10.
Split them into 4s and then 3 of those 4s.
No, I can't. What?
No, I got it. Wait, split them into 4s.
And then 3 into the 4th.
No, just watch. Wait, watch.
What?
Okay, so each one is 25. So
Oh, I
one
get it, I
ends
get it.
here, and then one ends here, and then one ends here.
Yeah, simple. See, I don't. Sorry. Okay. Wait, so should we just show the work of splitting it, or also like? No, I got it.
That wasn't weird. Don't judge.
Annie, this is what I did. I just did these few sentences showing that this line.
Yeah.
All of that is for one student.
Ian, I need another one. No, not pink or blue. No, which one? I don't care, not pink or blue.
Oh, really?
Just give me green or something.
Yeah, let's go with the chart.
Okay. Do we really need to color this? No.
Okay, good. I was gonna say,
Not working as well as I wanted to.
I had a feeling she's gonna.
Okay, so then 2 does not terminate using diagrams from the road without a
So imagine we have 3 cheese sticks. I hear some frustration because modeling can be challenging. If we want to be able to rewrite this as a decimal, we have to be able to represent things with a decimal. So if I split things up into halves, that's fine, but then both of those is going to be worth 8.5. And then half of a half would be worth 8.25, and it gets kind of funky. So you can do that, but it gets kind of awkward. instead if I split this up into tenths, now I can't copy paste very well right now, so I'm going to cheat a tiny bit. I'm going to use 3 different colors. So my red is my first cheese stick, or my first whatever I use. So I give 1 to person 1, 2, 3, 4. Everybody's got 1 now, right? And then 1, 2, 3, 4. Everybody's got 2 now. And then 1, 2. So we each have 2 pieces. Person 1 and 2 got a third piece. But now I move on to my second portion. Person 3 and 4. Now we each get 3 pieces. I can keep giving away. 1, 2, 3, 4. 1, 2, 3, 4. Perfect! Except I haven't given everything away. Right? So now I can do this again. 1, 2, 3, 4. 1, 2, 3, 4. And I end up with this chunk at the end. How much is that chunk at the end that I have yet to give away? 2 tenths. So, how can I split that up? Well, I have the 2 tenths like that. Well, to make 4 pieces, I can just cut it across. What will each of those pieces be now? 5 hundredths. Because instead of 10 hundredths, what this piece was worth, the 0.1, the 1/10, 10 hundredths, each one will be worth half that, or 5 hundredths. So what we ended up giving out is 7 tenths pieces. And then actually, if I wanted to use my base system, take the piece and cut it into 10, or like multiply by 10 again. So each of these tenths, we could have actually cut into 10 pieces to give them all away nice and easy. And then we would have handed out 1, 2, 3, 4, 5. And we would have handed out 5 of the 100th pieces. Or if we don't work in our base system necessarily, we can just kind of think it through. Half of 10 hundredths is 5 hundredths. Now, when we try to do that with the problem 2/3, I have 2 of something dividing to 3 people. So, if I box these out and make them tenths, we can do the same thing. And I'm going to give you guys the rest of the time to kind of model this out now that we did one together. So that's like saying, here's your whole quantity. And you don't have to box it. You could just like break it up. Or you could use like graph paper if you wanted. I mean, still, that goes back to like, so why do we long divide? What are we representing? Well, we're representing, I can take this portion and break it into tenths. Or I can take that, break it into hundredths. So you have to, we're really trying to justify so we understand the math. You know what I mean?
Oh, cheater.
We're just trying to be able to visually understand.
Okay, so then I'm doing it my way.
It's all good.
My way or the highway.
Let me see if I can pull up a little video that helps make sense of this.
It's a really bad joke, but I made it joke. Because we have a couple of stops. We were just here. We were just here. We were a couple of just here.
It's
So we could go like the back way or the highway. And I said, and I was like, she was like, what if we didn't take this? Where we would have? I was like, okay, the highway. And I went my way or the highway. The highway's my way.
Oh.
Man.
Guys, this splits perfectly. No, what? No, it was not me. I did not take your fidget spinner.
Yeah, this is all way too complicated. Let me try to just make my own model really quick.
I can't take it.
I swear he didn't take it.
Did I take it?
Yep.
Or did it fall on the ground and you're just really oblivious?
Someone took it.
Yeah,
But
I don't
not
know.
us.
I don't know.
All
who
right,
took it.
so I have just a couple minutes, and at the sake of nobody else has a good video for this, I'm gonna try to make my own. So I have two, whatever you want to say here. Say calzones. I'm feeling a calzone. So we have two calzones. Let's go ahead and-
Then what?
and 3 people. So we have 2 calzones. We're going to divide to 3 people. Now, if you've ever been to Pasquale's in Westerville, you'll understand their calzones are bigger than your head, and you can't eat the whole thing anyway. So, it's fine. So we cut them up into 10 pieces. So, as my graph paper shows you, sorry that it's just black border, but here's my big calzone. Visualize with me, right? So, I give a piece to person 1, then person 2, then person 3. Then person 1, then person 2, then person 3. Person 1, 2, 3. And I get the final piece left over. Now you, person 2 and 3 are like, that's not fair. I'm like, wait, there's a second calzone. Calm yourself. So we move on to the second calzone. Person 2 and person 3. Now we've each had, well, here was our first slice, our second slice, our third slices, our fourth slices. 1, 2, 3. Our fifth slices. 1, 2, 3. Our sixth slices. And we get to the end of our second calzone. And we can't give it away. Because there's 3 of us still, and we have to be fair. We all love fairness. So, we ask for the pizza cutter to come back out. And we asked them, can you cut this into 10 strips and 10 columns? And I wish I could zoom on this. So if you can visualize, I might be able to do it if I do this. Paint. I bet I can zoom on this if I paste this. I win. Sometimes ideas work out. So right here, my last calzone, right? We cut it 10 across and 10 vertically, and we end up with 100 little slices from each. And we go through and we person 1, 2, 3, person 1, 2, 3, 1, 2, 3. And we do that. The whole 100 here, the whole 100 here. And we end up with a couple pieces left over.
Oh my
And we have
god.
the pizza slicer come back out and we cut it again. 10 by 10 and we do it again. And we will do this forever. And never be able to give away all the pieces evenly. Ava. Shh. Ava. Because we don't have a way to write that. We don't have a decimal way to write that because our base system that we're trying to write it with a decimal. Now I do agree that if I could take this quantity, sorry I can't write ink in paint, if I could take that quantity and cut it into thirds, that will solve my problem, but how would I represent that as a number? It's a good solution, but then that leaves us another question. Have a great day, guys. We'll see you tomorrow. Yeah. Well, yes, but then we're going to start the process all over again.
Either your color or
Yeah.